Hello everyone, my name's Dr. Vile. Welcome to my YouTube channel designed to help you through your A-level chemistry. The purpose of this video is all going to be about balancing chemical equations. If you find this video helpful, please like, please share, and please subscribe to the channel. So we're going to be looking at how to balance chemical equations. It's easiest to show this with examples, so we're going to work through 6 different examples, including some exam questions. This video does assume that you know how to write formulae already. So if you don't know how to write chemical formulae already, you'll need to check out the videos on writing chemical formulae. So I'll start with a nice, relatively straightforward example. You've got H2 plus O2 going to H2O. And this is what we call an unbalanced equation, where I've written down all the formulae correctly, but there is no balance in the amount of these atoms on each side of the equation. And the general principle for balancing an equation is that you need to have the same number of atoms on both sides of the arrow. So you've got to have the same number of hydrogens, the same number of oxygens on both sides of the arrow. And the only way that you can do this is by having multiples of each of the terms. You cannot change the formulae to get this to work. So a common misconception that people can do is that they can just stick a little 2 next to the H2 and the O2 there. Now I've got 2 on each side of each, and that's okay. You cannot do that to balance this equation. We can only balance with multiples. So the first thing I would notice is that there are 2 oxygens on the left hand side and only 1 oxygen on the right hand side. So what we do is we double the amount of water. So I've now got 2 water molecules being formed. This gives me 2 oxygens on the right and 2 hydrogens, 2 times 2 hydrogens on the right, which gives 4 hydrogens. And therefore we need to times the amount of hydrogen by 2 as well. And now hopefully you can see on the left hand side that you've got 4 hydrogens and 2 oxygens, and over here you've got 4 hydrogens and 2 oxygens. So this equation is now balanced. In the second example, we've got Na plus O2 goes to Na2O. I would start by balancing the oxygens. You've got 2 on the left hand side and only 1 on the right hand side. So therefore I need to stick a big 2 in front of the Na2O, which balances the oxygens. In terms of the sodium, you had 2 sodiums, we're timesing by 2, which gives 4. Therefore I need to put a 4 in front of the Na. And that equation is now balanced with 4 sodiums and 2 oxygens on each side. In the next example, we've got Fe2O3 plus Al goes to Fe and Al2O3. This is relatively straightforward to balance. You've got 3 oxygens on each side, so we don't want to do anything that messes around with that. I've got 2 ions on the left hand side, so I need to times the Fe on the right hand side by 2. And I've got 2 aluminiums on the right hand side, so I need to times the amount of aluminium by 2. And now this equation is balanced. Just imagine that there's like a dividing line here. I've now got 2 ions, 3 oxygens, and 2 aluminiums on each side. So that is now balanced. Here we've got calcium carbonate, CaCO3, reacting with hydrochloric acid, HCl, to produce calcium chloride, carbon dioxide, and water. The first thing that jumps out at me is that the chlorines do not balance. You've got 2 chlorines on the right and only 1 chlorine on the left, so we have to double the amount of HCl by putting a big 2 in front of it. And actually, if you go through and count the atoms now, you've got 1 times calcium, 1 lot of carbon, 3 oxygens, 2 hydrogens, and 2 chlorines. And we can actually go through and count those and cross those off. So 1 calcium, that's here. 1 carbon, that's here. 3 oxygens, that's here, here, and here. 2 hydrogens, that's here. And 2 chlorines, that's here. So that equation is now balanced as it is. We don't need to do any more to get that to balance, just by putting a 2 in front of the HCl. So far, these have all been moderately easy. We're now going to look at a couple of exam question ones that are a little bit more challenging. So here you've got C12, H22O11 reacting with just oxygen to produce COOH in brackets 2 and then water. Right. My little tip here is that we're going to leave the oxygen till last to balance, because I can put whatever number I need here without it affecting anything else. So I'm going to start with the carbons. There is 1 carbon inside the bracket and we're timesing it by 2, so that gives 2 carbons. We need to have 12 carbons, therefore we times all of this by 6. That gives me 12 carbons. So you can make a list here as we go through. 12 times carbon. Now inside the bracket there is 1 hydrogen and we're timesing it by 2, so that's 2. Timesing it by 6 gives you 12 hydrogens, and we need to get to 22 hydrogens. That means we've got a deficit of 10, and therefore we need 5 H2Os to balance. And as I say, that gives you 22 times hydrogen. And we've done everything except for the oxygen. This is perhaps the most challenging bit. Inside the brackets you've got 2 oxygens, but we're timesing by 2, that gives you 4. And we're timesing by 6, that's 24 oxygens, plus 5 oxygens here, that gives you 29 oxygens in total. But you've already got 11 here, so we subtract that away, that gives you 18 oxygens, and therefore this number here must be 18 plus the 11, which gives you 29. Oxygens. And then lastly, we've got this rather intimidating looking equation. The key is to start here and just work out what you've got, and we'll once again leave the oxygen till last. So here you've got 4 coppers, so it has to be a 4 here. We then have 4 ions. Well, you've got 2 here already, so this must be a 2 to balance the ions, because that gives you 2 here and 2 here. And then you had 2 sulfurs here, but you're timesing by 4, which gives you 8. That means that this must be an 8 as well, and we don't need to put any number here. And then all we have to do is work out how much oxygen is on the right hand side. So that's 2 here, plus 3 here gives you 5, plus 8 times 2, which is 16, so 16 plus 5 is 21. Therefore this number must be 10.5. And at the end you can always go through and just double check that you're happy with everything. So we've got our 4 coppers, 4 ions, 2 ions, 2 ions make 4 ions, 8 sulfurs, 21 oxygens, so we're happy with that. Thank you for taking the time to watch this video. I hope it was helpful. If you have found it helpful, please like, share it, subscribe to the YouTube channel, and keep looking back for more content.